Section 8.4 talks about testing a claim about a mean. Once again, this is one of the most important sections in this book, highlighted right here. Part 1 will talk about the very realistic and commonly used case in which population standard deviation is not known. Part 2 discusses what happens when a standard deviation is known for the population. Once again, very rare here. So vast majority of our problems will be coming from when the standard deviation is not known. Okay, once again, requirement of normality or n is greater than 30. This t-test, okay, once again, remember our t-test that we discussed on here. So if we come over to that next page here, we talk about testing claims about the population. So we're going to have n for a sample size. X bar is our sample mean, and then mu sub x bar is our population mean. That means this value is taken from the claim and is used in the statement of the null hypothesis. Okay, so requirements. The sample is a simple random sample. Either or both of these conditions are satisfied. The population is normally distributed, or n is greater than 30. Okay, so once again, if we have n greater than 30, we do not have to worry about any normal distribution. Once again, our test statistic talks about t test equals x bar minus mu x bar over s divided by the square root of n, where s is our sample standard deviation. Once again, we'll have our p-values, degrees of freedom, n equals 1, and then critical values itself coming from our student t-test given in our indexes. So one of the things we're thinking about on here are important properties of this. So as we look at these important properties, the student t-test is different from different sample sizes. The student t distribution has the same general bell curve as a standard normal distribution, but it's wider. Has a mean equal to 0. Standard deviations in the sample are greater than 1, and has a sample size. N gets larger, the student t-test gets closer to a standard normal distribution. Okay, so once again, as we get larger, everything gets to be a little bit better. One of the things in our calculators that we'll start referencing here is you'll see the symbol right here, t-test. Okay, so once again, that's something as we start going through with our calculators, we'll start referencing everything that's happening here. Continuing on in the section, we start talking about confidence intervals down here. We can use a confidence interval for testing a claim about mu. For two-tailed hypothesis with a confidence test of 0.05 significance, we construct a 95% confidence interval. But for a one-tailed hypothesis test, a 0.05 significance, we construct a 90% confidence interval. So something that we want to pay attention to. Once again, this is page 430. Going through page 430 is what this was found on. And then the part 2, once again, briefly describes the fact that what happens when the standard deviation is known. Once again, here we have to have, you will use our Z-test on this. Once again, I've got our parameters that go with the critical values, just like we did in the student t-test part of it. And our data right here, once again, Z-test. For a hypothesis test claim involving one population. Okay, so we got our calculator. It's going to be setting up and doing most of the work for us once again.